All right, so in this video, I'm going to explain everything you need to know about Soh-Cah-Toa. Soh-Cah-Toa, Soh-Cah-Toa. Very important concept. Very important acronym. Soh-Cah-Toa. So I'm going to explain everything you need to know about this right here. But before I get started, I want to reiterate that there is an important difference between degrees and radians. Both are a unit of measure of an angle. So we've seen and we've discussed this before that if we're looking at a circle with a radius of 1, we can kind of view this concept in terms of radians or degrees. So if we were going around, this is a straight line. If we were going to say, well, what is that, the measure of that angle right here? Well, that's just 180 degrees. So this is 180 degrees. And we've said that we've defined 180 degrees to really equal pi radians. And we said earlier that a radian is a dimensionless unit. So a radian really is equal to the number 1. So 180 degrees is equal to pi times the number 1. So pi times the number 1 is really just pi. So 180 degrees is really just pi. So it's pi radians or just pi. And if we were going to cut this thing in half, so this from here to here is 180 degrees. If we were going to cut it in half, well, we take 180 divided by 2, and we see that this is a right angle. So this would be an example. So this would be 90 degrees right there. In other words, it would be, so this was pi radians, so this would be pi over 2 radians, the measure of just that angle right there, or just pi over 2. So, and again, why this is so important is that what we input, either 90 degrees or pi over 2, into these values here, it will change our answer. And we discussed how to convert between degrees and radians. The way you do that is with canceling out units. All right, let's talk about Soh-Cah-Toa. All right. Now, in the last video, and what we've discussed, at least in class, is that sine, cosine, and tangent, we talked about what all these things are. So here's sine, cosine, and tangent. These are all what are known as trigonometric functions. So this would be an abbreviation for sine, and we say sine of theta. So the reason, so theta is just an angle. The reason we're using this fancy looking symbol here is because in context, we always say points are capital letters. By convention, they're capital letters. Sides are lowercase letters. And then we're running out of letters, so we go into the Greek world. So this is what we use for typically the angle, the measure of an angle. So this would be sine of theta, this would be cosine, and this would be tangent. And again, all of these values, we see here that all of these trigonometric functions, they include some angle inside them. You will never see sine, cosine, or tangent with something other than a measure of an angle inside of it. So you will always have an angle inside of sine, cosine, and tangent. It's always in reference to that. All right, so I'm going to go over some examples, and we've talked about this means opposite over hypotenuse. This stands for adjacent over hypotenuse. This stands for opposite over adjacent. So that's what all these terms are equal to. Okay, so now I'm going to just cover some examples here. All of these are in reference to right triangles. So let's say we have a right triangle. So this is 90 degrees. The angle opposite the 90 degrees, well, that across from is the hypotenuse. So this is the hypotenuse. Let's just say this value is 10. It could be feet. So whatever unit. So let's just call this distance from here to here 10. let's have this side be x, and let's make this angle 5 degrees. Okay, so and we're wanting to figure out what the measure of that side is right there. What is x equal to? This is 10 feet. What is that distance? Well, Soh-Cah-Toa is how we figure that out. So what I do is I start off by writing Soh-Cah-Toa. And I realize that if I get two sides here for any of these values, that will specify what I'm using, either sine, cosine, or tangent. Okay, so I'm going to go through that now. Well, right away, so you got to just start off by identifying the side. So first off, I wrote Soh-Cah-Toa down. I identify this side right here. This side is given. It's the hypotenuse. It's the side opposite the 90. So what I do is I check off H, hypotenuse, for all of those. Everywhere I see an H, I check it off. Then this side right here, so I'm looking at this X right here. Well, this is my angle that I'm in reference to. This is the side that's opposite. There's nothing here. So there's nothing here. The side that this angle is connected to, this X, is called the adjacent side. Adjacent starts with the letter A. So right here, I'm looking at adjacent. So everywhere I see an adjacent, an A, I check it off. Notice I have two check marks right here. So I'm going to, what this means is that I am going to use cosine in this context. So I'm going to write cosine, because I have two check marks there and there, of some, what goes on the inside right there? Always, always, always the angle. Whatever is going there, this would be theta, this is the angle. So you put the angle right there. So I write cosine of 5 degrees is equal to, again, this is not saying adjacent times hypotenuse. All of these terms, opposite over hypotenuse, they're fractions. Adjacent over the hypotenuse, opposite over the adjacent. So cosine of 5 degrees right here is equal to the adjacent side. So the adjacent side, they're all fractions. So adjacent goes up here. So I write an X. The hypotenuse is 10. So I put a 10 down here. Again, so this would be A over H. So from here, we just solve for X. So what I'm going to do here is I'm going to multiply both sides by 10. So this says 10 times cosine of, here, that was a badass. 10 times cosine of 5 degrees is equal to X. All right. Now, when I type this in on the calculator, it's very important how I type it in. Okay. So if you have a calculator, let's say you have a calculator that looks like this. What you're going to have to do is you're going to have to make sure that your mode is correct. So what you want to do is you want to look at it, and you see that there's this button right here. It says mode. So you click on the button that says mode. And then what you want to do is you want to make sure that you're in degrees. Okay, we're using degrees. If you're not in degrees, change it. So let's say you're in radians. You want to scroll over to degrees and hit enter. The reason we're in degrees right now is because you see the 5 degrees. We're dealing just with degrees. It will mess it up. It will be a different number. This will be in radians if you're in the wrong mode. So make sure you're in degrees. So I'm in degrees. Then what you want to do is you want to hit second quit. So I hit second mode, quit, and that exits me out of the window. All right, so what I do now is I go 10. So I write 10 times cosine. It's the COS on this calculator. So I type cosine of 5. And since we're in degrees, I can close it off. It's going to assume that number is in degrees, that 5. All right, so I hit 10 cosine of 5, and that number comes out to be 9.96. So that number right here, X, is approximately 9.96. Now, does that make sense in context to this problem? So if we look at this triangle here, 5 degrees looks like this. It's really smushed down. Here is my hypotenuse. It's 10. It's always going to be the biggest side as a means of checking your work. So there's 10. This 5 degrees is a small angle. Notice this side right here is about the distance of this side. So this value right here, it should make sense. So whenever you're done with the problem, make sure you go back and you check your work and make sure it makes sense as to what the numbers actually are saying. So if this was 10 feet, this would be about 9.96 feet right here. All right, let's go into another one. Let's say I have an angle here. Let's say this is 30 degrees. This is 90 degrees. And let's say the hypotenuse is 20 feet. And I'm wanting to figure out what this side is. So I write an X here. So I have some measurements, and you know, you can really see the application of this now. You have an angle, a 90 degrees. You're trying to figure out what that is, right there. So again, how do we start this off? The first thing you always want to do is you want to write down, what is it? You want to write down, I can't remember the acronym. Make sure you're spelling it out right. Soh-Cah-Toa. Toa. All right, Toa. Okay. So I write out Soh-Cah-Toa. Now I start identifying. So I wrote Soh-Cah-Toa. I start identifying. I need 2 of these to declare what I'm going to use. So I'm looking at, there's my angle that I'm in reference to. Well, this is the side across from, it's opposite that angle. So opposite, this is the opposite side. So I put a check mark next to every O. I see an O. O there and O there. So I'm either using sine or tangent. I'm not sure quite yet. I need 2. Well, this side right here, oh, that's 20 feet. So there's 20. So, all right, I see this is the hypotenuse. It's opposite the 90. So, oh, there's an H and there's an H there. So I put a check here and a check here. All right, oh, I have 2 check marks. That tells me I am going to be using sine. So I write sine. Put a parentheses around it. It's a good habit to be, it's not sine times this, it's sine of this angle. So this is a specific number right here, sine of 30 degrees. Always put the angle inside that. All right, sine of 30 degrees is equal to opposite over hypotenuse. So I'm put a fraction. Over means it's a fraction. Look above. This is the O, opposite over the hypotenuse. So opposite over hypotenuse. The side opposite the angle, well, this side opposite the angle is just X. So I put an X here. And then the hypotenuse, well, that's 20 feet. So I put a 20 over here. Now, at this point, I multiply both sides by 20. I get 20 times sine of 30 is equal to X. Then I go in my calculator, I type in 20, and then I look for that sine of 30. Then I close it off. 20 sine of 30, and this is in degrees, so I can just leave that 20 times sine of 30, and then I get the number 10. So I get the number 10. So X here is equal to 10. Now I look back up and I say, oh, this was 20 feet. So X, oh, this must be feet over here. Remember the units at the very end. So what this says is that this distance from here to here, if this is 20 feet, this angle was 30 degrees, X must be equal to 10 feet. Therefore, we conclude that. All right, let's talk about the final example here. This is example 3. All right, given some right triangle. Say we have this is x. We're trying to figure out what x is. Let's call this 7 inches. Let's say that this angle right here, let's make this be 60 degrees. Remember, if this was just left blank, so 60 degrees right here. All right, so well, this is going to be in inches right here. So let's get into it. First step, what do? Write down Soh-Cah-Toa. Step 1, write down that. So finish writing that down. Soh-Cah-Toa. Soh-Cah. Now how do you spell it from there? Ka. T-O-A. Okay, so sorry, write down my Soh-Cah-Toa here. Alright, so you look at this angle here. There's 60 degrees right here. So it's 60 degrees. Looking in reference to this angle. I don't have the hypotenuse. That's not given. I see this side right here. Oh, this is the side that it's attached to. The side that it's attached to, well, that's my adjacent side. So I look above and I see, oh, there's my A right there. Oh, there's an A right there. I need 2. This side, oh, this is the side across opposite this 7. Oh, so opposite. I have the side opposite, so I look above. Where's an O? O stands for opposite. Oh, so I have this. I'm putting a check mark next to everything I see in O. Oh, that means I'm going to be using tangent here. So I write tan. Okay, so I have the 2 check marks. I'm going to be using tangent. So I write tangent of, well, what goes on the inside? It's not the side. Do not put the side in there. Every single one of these trig functions, you're going to have an angle going here. Never put a side in there. It's going to always be an angle. Put your 60 degrees in there. So tangent of 60 degrees. Then I write an equal sign. They're all fractions here. I put a fraction. Opposite. I'm getting opposite. Well, what's the side opposite? Well, that's 7, so I put a 7 here. Over adjacent. What's the side adjacent? Oh, that's x. Oh, no, we have x in the denominator. How do I get x out of the denominator here if I had this right here? Yes, I multiply both sides by x. So I multiplied both sides by x. I got to get it out of the denominator. When I do that, the x cancels out on this side, so the x kind of swings around over here. So I have x tangent of 60 is equal to 7. I multiplied both sides by x. It's looking better. I have x out of the denominator. Now what do? Very good. I divide both sides by that entire quantity, tangent of 60 degrees. I divide both sides by that entire thing. So this is just some number, so I divide by tangent of 60 degrees. This whole thing is just some number. That cancels out. What that means, therefore, so I have x equals, what's that? 7 over tangent of 60. All right, what's that number going to be? All right, so I type in here, so I go 7. So I type in 7 divided by, and then I have 7 divided by tangent, 7 divided by tan, I type in T-A-N, of, well, this is 60 degrees, so I type in 60, then I do the parenthesis, all right, so I got 7 over tan 60. Oh, that number I'm getting is about 4.04. And then I look above, oh, I was dealing with inches. This must be inches here. So this, oh, that's inches. So the distance for x right here would be 4.04 about inches. Now, this is going to be the last example. So, and I'm going to talk about this example here. And the reason I'm going to talk about it is that I think it's a very super important concept, okay? We all need to know how to determine what angles are. Okay, so what happens is, let's say that this was 10, let's say this was 20, and let's just say we didn't know what this angle was. So here's theta. We don't know what that is in degrees. Let's say this side was 10 inches. This is example 4. Let's say this side was 10 inches right here. This side has to be longer, so this is 20 inches. Let's say we are given two sides and we want to know what that angle is right there, that theta. So what I do here is I'm looking at what I have above. I'm just concerned about the sides here. So I see, okay, so here's theta. So I'm going to write cos. Okay, this is adjacent and hypotenuse are given. So I have adjacent and hypotenuse. So I have the two. I have the adjacent and the hypotenuse. That means I'm going to use cosine here. So I write cosine. Now, theta is just some value. So this is my measure of my angle. So what goes inside here is just theta. All right, cosine of theta is equal to, well, it's adjacent over hypotenuse. So adjacent, this is adjacent. So I put a 10 above. The hypotenuse is on top, so I put a 20. Now, this is an interesting topic here. So what I can do to figure out what theta is, and I'm going to show you some fancy notation here. So theta would be equal to the inverse of cosine, so there would be 10 over 20. A lot of times you will see this even represented as theta is equal to a cosine of 10 over 20. These mean the same thing. What the A stands for here is A for arc length. So arc length is the distance from here to here. So it's the measure of your arc. So, but it's commonly used. So A stands for arc length. So it's going to give us what that value is right there. So, but it's commonly used for this right here. So it's used, this is the most common notation right here. What I do, well, 10 divided by 20 is, everyone knows that that is 10 over 20, it's 0.5. So I write a 0.5 there. And then to figure out what theta would be, to figure out what that angle would be, what I'm going to do is I'm going to go up here, and so I look here, and then what I see is, so here's a cosine. Here's my cosine value. If you look right above it, it has the cosine inverse value for it. So if you look right above cosine on your calculator, right above it, you have that inverse cosine. So I'm going to hit second cos. Notice what happens on my calculator. I have that cosine, I have that little negative 1 above. So I have that arc cosine. And then I type in 0.5, I close it off. And so what I end up getting, I end up getting 1 point, okay. Why did I do that? Oh, it's because I'm using a different calculator here. I have to go in degrees. This goes to show you there's an important, you have to make sure your calculator is in degrees, otherwise it won't work. So I hit second cos 0.5, and then I get 60. I get 60 degrees. So theta will be 60 degrees. And that's how you figure out what angles are. And I want to make sure that everyone knows how to, compute what an angle is. So you want to take the inverse of it on that other side, and you go from there. Okay. I hope everyone has a great summer. I wish I was there in class. I wish I could see you all in class. It's been a great year. I wish I could be there. Have a great summer, everybody. Okay.